What we see here is the quadratic formula used for solving quadratic equations, and the discriminant is part of the quadratic formula. It's b squared minus 4ac. Now this can have one of three values. If b squared minus 4ac is greater than 0, it means that there are two real distinct roots. So what we might expect to see then is our quadratic function, whatever it is, cutting the x-axis at two distinct points, here and here. Now we could take a specific example. So we have the quadratic equation x squared minus 4x plus 3 equals 0. Well, we know that a equals 1, b equals minus 4, and c equals 3. b squared minus 4ac is minus 4 squared minus 4 times 3 times 1. So that's 16, take away 12, which is 4. And since 4 is greater than 0, this quadratic here, should we choose to draw it, has two real distinct roots. b squared minus 4ac sometimes has the value 0. And if it does, we would expect to see our quadratic function touching the x-axis. We're not cutting through it. Which is to say, if b squared minus 4ac equals 0, then we have one real repeated root. An example of that might be x squared minus 6x plus 9 equals 0. Now we know that a has the value 1, b has the value minus 6, and c has the value 9. So b squared minus 4ac is minus 6 squared minus 4 times 1 times 9, 36 minus 36 equals 0. So this function here then has one real repeated. If b squared minus 4ac is less than 0, it means we have no real roots. And an example of such a situation might be when we have a quadratic function doing like so. So our quadratic does not touch or cut the x-axis at any point. There are no real roots. And an example of this might be something like, so 2x squared plus 3x plus 7 equals 0. We know that a is 2, b is 3, and c is 7. b squared minus 4ac is 3 squared minus 4 times 2 times 7. 9 minus 8 times 7 is 56. So that would be minus 45. And since b squared minus 4ac is less than 0, this function here has no real roots.